Okay, let's dive right into this explainer and solve a literal 4,000-year-old culinary cold case that has left millions of us in tears. I mean, we've all been there, right? You're standing at the kitchen counter, wiping your eyes with the back of your wrist, just wondering why making dinner has to be such an intense emotional ordeal. Well, today, we're treating this everyday annoyance exactly like what it really is, a crime scene. We're going to look at the victim, which is you, and the tiny microscopic weapons being deployed against you.
Welcome to a scientific detective story, where we're asking the ultimate kitchen question. Why do onions make us cry like we're watching a sad dog movie? Seriously, think about it. You can chop carrots, potatoes, celery all day long, with zero emotional impact. But the second you slice into this one specific root vegetable, your eyes well up, your vision blurs, the whole shebang. To figure out how to stop this, we have to look way past the old wives' tales and dig into the actual biology, the chemistry, and as we'll see in a bit, the cutting-edge physics of food prep.
And you know, this isn't a new problem. Humanity has been battling this vegetable for 4,000 years of continuous recorded use. For millennia, onions have made their way into pretty much every single culinary tradition on the planet. We basically love to hate them. Or I guess our eyes hate that we love them so much. For thousands of years, cooks have just accepted the tears as the price of admission for all that flavor. But what's absolutely wild to me is that despite thousands of years of exposure, we only recently cracked the case of how this vegetable actually fights back. Now, to solve any crime, we need to identify the culprit. And the prime suspect in our kitchen drama is a chemical weapon called synpropanethyl S-oxide. Yeah, it's quite a mouthful. Basically, it's a volatile airborne compound that targets your eyes with terrifying precision. When it hits your cornea, it sends a massive red alert to your nervous system that a dangerous irritant just arrived. That alarm forces your tear-producing glands into absolute overdrive to flush it out. But guys, here's the most devious part of the onion's defense mechanism.
The biggest twist in this whole investigation is that the onion doesn't naturally contain this chemical at all. It doesn't. If you hold a whole, unpeeled onion right up to your face, literally nothing happens. It's completely harmless. The onion only holds the raw ingredients to build this weapon, and it keeps them safely separated in different microscopic compartments. It essentially sets a biological booby trap, just waiting in absolute silence until you, the cook, make the decision to strike first. The exact microsecond your knife hits the flesh, it triggers a three-step chain reaction. Boom. Step 1, your knife violently breaks open those cell walls. Step 2, this introduces an enzyme called alliinase to the air, which instantly forms a compound called 1-propanil sulfonic acid. Then, step 3, that acid reacts with a second enzyme to become our actual culprit, synpropanethyl S-oxide. And incredibly, that final step, the exact moment the actual tearjerker substance is formed, was only discovered by chemists in 2002. Given our 4,000-year history with onions, 2002 is basically yesterday.
Actually, quick, fascinating side note before we move on to the physics. There's a crazy environmental twist to this chemistry. Have you ever felt like onions were just way harsher when you were a kid? Well, you might not just be getting tougher. The onions might actually be getting weaker. See, onions pull the sulfur they need to build these chemical weapons directly from the soil. Because acid rain contains a lot of sulfur, the incredible success of modern environmental efforts to reduce acid rain means there is literally less sulfur in the ground now. So that might actually be making today's onions slightly milder than they were a few decades ago. Pretty cool, right?
Okay, so the chemists finally figured out what the weapon was, but the physics of the attack? That remained a total mystery. We had mapped the chemistry, we knew the biology, but how exactly was it traveling from the cutting board to our eyeballs? It's an unstoppable molecule once it hits your eye, so the only way to truly win this battle is to prevent it from launching in the first place. But how in the world do you stop an invisible chemical delivery system?
To find that missing puzzle piece, researchers at Cornell University published a groundbreaking study in October 2025. And to eliminate human error and map the exact physics of the chop, they deployed a highly scientific, precisely tuned contraption. They called it the onion guillotine. I love this. They weren't just chopping vegetables. They were executing a highly controlled, high-tech sting operation to capture this invisible delivery system right in the act.
The Cornell team didn't just use a fancy slicer either. To really build their case, they surrounded this onion guillotine with an impressive high-tech toolkit. We're talking high-speed cameras, an electron microscope, the works. They wanted to capture exactly what happens at the microscopic level at the exact moment of impact. So, they meticulously tested a bunch of variables, altering the knife's sharpness, the angle of the blade, the speed of the cut, even the temperature of the onion itself, all to see what resulted in the worst possible onion juice splash.
And what those high-speed cameras revealed was a massive breakthrough. They discovered that the chemical doesn't just mysteriously vaporize into the air as a gas. It's actually carried inside an airborne spray of microscopic droplets. The footage showed this violent, direct, initial burst of microscopic droplets launching right up into the air the second the blade punctures the surface. That's followed by a slower, continuous release as the blade travels all the way down through the tissue. So the weapon isn't a gas at all. It's a microscopic liquid projectile.
This discovery completely changes how we need to look at our kitchen tools. Just look at this comparison. When they tested a blunt blade, they saw it applies extreme, crushing pressure to the cell membranes before it finally breaks through. It's exactly like stepping on a water balloon. It causes a massive, violent explosion of droplets right up toward your face. But a sharp blade slices cleanly through the membrane with minimal pressure, which significantly reduces that droplet explosion. Plus, obviously, a sharp blade requires less pressure, which keeps you way safer from the knife slipping anyway.
The investigation also looked at speed. We've all seen those frantic TV chefs hacking away at 1,000,000 miles an hour, right? Well, the high-speed cameras revealed that cutting at high velocity creates a chaotic, significantly larger release of droplets. Every single high-speed impact launches more microscopic payloads into the air. The data is super clear here. A slow, cautious, and steady cutting pace is absolutely your best defense against this airborne chemical attack.
Okay, let's put those famous internet kitchen hacks on the witness stand and look at the actual evidence. Hack number 1, chill your onion in the fridge. The Cornell team found this completely backfired. The cold actually makes the onion tissue stiffer, meaning they absorb way more of the knife's pressure before finally snapping, so they burst with even greater energy. Hack number 2, leaving a damp towel or a bowl of water nearby. Plausible in theory, sure, but the physics show that droplets fly rapidly upwards from the board. Water sitting down flat on the counter is only going to mop up the bounces. It completely misses the main vertical attack on your eyes.
But here is where this gets really serious, because this Cornell physics study isn't just about avoiding a kitchen annoyance. It's actually a massive, game-changing revelation for general food safety. By proving that cutting vegetables creates this highly energized spray of invisible microscopic droplets, they've uncovered a hidden dynamic that is happening on our cutting boards every single day. The tears, they're just the symptom we can actually feel.
Think about the broader implications for a second. If an onion is launching droplets 2 feet into the air, so are your other vegetables. And these flying droplets don't just carry tear-inducing chemicals. They can act as high-speed transport vehicles for dangerous foodborne pathogens. If you've got bacteria on your cutting board or on the surface of your produce, a blunt knife is effectively aerosolizing it. It's spreading it all around your kitchen workspace. So keeping your knife incredibly sharp isn't just about showing off your culinary technique. It literally stops the spread of microscopic bacteria and keeps your whole kitchen sanitary. So, to close the case on this explainer, here is your ultimate science-backed solution for this 4,000-year-old onion problem. First, ditch the fridge hacks and the water bowls. They just do not stand up to the physics. Second, make sure you're using a dangerously sharp knife to slice those cells rather than crush them. Third, cut slowly and deliberately to minimize your splash zone. And hey, if all else fails and you've got a mountain of onions to get through, just give in and buy some safety goggles. Funny enough, that's exactly what professional prep cooks have been doing for years to physically block the droplets.
It's honestly incredible how a simple, everyday annoyance opens the door to microscopic physics, chemical booby traps, and the surprisingly chaotic reality of food prep. As we wrap up this investigation, I really want to leave you with this provocative thought to ponder the next time you're cooking. If blunt knives are launching invisible chemical payloads from our onions right into our faces, what else is bursting off our cutting boards completely unseen? Take care of those knives, take your time, and enjoy your tear-free cooking.